So here's another question that involves Rolle's theorem, which asks if us to determine whether or not Rolle's theorem can be applied on the given interval. If not, explain why not, or if so, let's find some value and see where it does. Well, in this case, we've got the function y equals 3 minus the absolute value of x minus 3. And the question is, well, does Rolle's theorem apply? Well, Rolle's theorem applies under the following conditions. Number one, the function has to be continuous. So we ask, is f of x continuous? The answer in this case is that the function, yeah, over the interval from 0 to 6 is a continuous function. At every point between 0 and 6, including 0 and 6, f of x, y, is defined. We can substitute in 0, we can substitute in 6, we can substitute in any number in between, and we find that this function is continuous. But the question might come up, is f of x differentiable at every point in between? Well, now how do we know that one? The only way for us to determine whether or not a function is differentiable at every point is to look to see if there are any points at which this function's derivative might not be defined. And there is one such place, and it involves this absolute value bracket. Recall the definition that we stated earlier about absolute values, which is this, that the absolute value of any quantity is either equal to itself if that quantity is greater than or equal to 0, or is its opposite if that quantity is less than 0, if it's a negative number. Now in this case, we've got that absolute value of x minus 3. So what this definition is interpreted as in this case is the absolute value of x minus 3, which is the same thing as saying x minus 3, let me get my eraser here, the same thing as saying x minus 3 itself whenever x is greater than or equal to 3, and it's equal to its opposite, the negative of x minus 3, whenever x is less than 3. And the reason why that's important to us here is that, in fact, this absolute value piece of the function gives us a piecewise function, and we know that sometimes if it's the case that we have a piecewise function where the behavior changes at a point, it is possible that its derivative will not exist at that point. So we have to look to see if that's the case here. So I'm going to rewrite this function. We know that the function's behavior changes at x equals 3, so what we really want to determine is whether or not the function is differentiable at x equals 3. So we want to ask, is f of x differentiable at x equals 3? X equals 3. Question mark. There we go. Okay, is it differentiable at x equals 3? Well, the way that we found out, the way that we explored differentiability was whether or not a certain limit exists. In this case, I'm going to use another definition. You recall this limit definition that told us that if we were just interested in finding out whether or not a function derivative existed at a point, f prime at that point, the derivative at that particular point, would be the same as the limit of the function f of x minus f of c divided by x minus c. So our question right here is, is this the kind of function that limit would exist at c equals 3? So we explore it. Let's take that limit as x approaches 3 of f of x. Well, f of x, here it is the quantity 3 minus the absolute value of x minus 3 minus f of c. Well, what's f of c? Let's see, y at c equals 3. Y of 3 is equal to 3 minus the absolute value of 3 minus 3. We're just replacing x with 3. So y of 3 is equal to 3. All right, so we've got f of x minus f of c divided by x minus c. Well, this might actually look familiar to you because we've dealt with this kind of limit before. We're trying to determine whether or not this limit exists, whether or not the limit as x approaches 3 of the quantity negative absolute value of x minus 3 over x minus 3 exists. Now, if you recall, because we stated this definition up here at the top, that the absolute value of x minus 3 behaves differently to the left and the right of 3, we can actually come to the conclusion that no, this limit does not exist. Because the limit as x approaches 3 from less than 3 is like saying the negative of x minus 3 divided by x minus 3, and we know that that limit becomes positive 1 as x approaches 3. On the other hand, if we took the limit as x approached 3 from the right of the quantity, let's see, it'd be just negative of the quantity x minus 3 this time, just carrying that negative that's in front right here, over x minus 3, and we know that that comes to negative 1. And we say that since the limit as x approaches 3 from the left and the right don't match, then this limit does not exist. And so we say that, well, at x equals 3 then, f of x is non-differentiable. Since it is not differentiable, continuous but not differentiable, we say that Rolle's theorem cannot be applied. And this is the reason why.